Today we're showing off a fun project that we did. We wanted to see if we could get hobby-level electronics to interface with Lego robot hardware. This is the Lego Spike. This is a little robot built from the Spike ecosystem. This is the Lego Hub. It's just a device running MicroPython is really all it is. And then there's a couple motors I have on here. And I wanted to see if I can replace the hub with a SparkFun breadboard. And it turns out you can. It's actually kind of easy to do. The hub on here, it's got 6 ports for plugging your devices into, and all of the Lego devices, they use a standard connector on here. This is called the Lego Powered Up connector, or LPF2, or sometimes called We Do 2.0. Goes by a bunch of different names, but they're all the same connector. This connector is proprietary, so there's not really anything off the shelf that we can use with this. However, it's actually really easy to bypass by just crimping on a second connector. This is a very standard connector for ribbon cables. It uses a technology called insulation displacement connector, or IDC. It's just got metal blades that pierce through the insulation to make electrical contact. So you just take the 2 parts and just squish it on. Then you've got a brand new connector on here. This is an industry standard connector. And you can actually just, these are standard 0.1 inch headers, so you can plug jumper wires straight into this. So what I have done is, if we pop this off of here, I have 3D printed this little adapter for the SparkFun breadboard, and then it's also got a battery compartment down here, and then I can just plug in the power when I'm ready for that. As well as there is a hole pattern here for the Lego Technic pins, so we can pop these out of the Prime hub and pop this into my little 3D printed thing. So we just put those in there, bam, and then we can snap that into the same spot that the Prime hub was. There we go. So now we have a different hub device. And in order to drive these motors, 2 of the pins on here are for making the motors go forwards and backwards, and it just needs to be driven by an H bridge. So what I have here, this is a motor driver that is designed to go onto the R3 form factor that is used by the breadboard. And so what we can do is we can just get those pins aligned. And now I've got a motor driver on here, and I've got the wires into the screw terminals, and I just need to plug those into the connectors on here. And once I do that, then now I can control the motors from this setup here, just using hobby electronics to drive some Lego motors. And also we can add some new features on this, because this is a stackable ecosystem for these shields that we made. Here is the Red Vision touch display shield for breadboard, and so I can add this onto my stack here. There we go. And I have some code that I've loaded onto this, that when we plug this in, then you'll see there is actually an interface for selecting different programs on here. The thing about the Spike hubs is that they have just a simple 5x5 matrix display that your programs are numbered 0 through 19, whereas here you can actually see the name of all your programs, so you don't have to remember which program corresponds to which number. So kind of a nice little interface there. And then if I run this little drive demo, then this one's really simple. It's just demonstrating that I can drive the motors, so I can tap on forwards and backwards, and then the row right and left, and I'm driving the motors. It's really kind of that easy. That's all you need to do is just get an H bridge, plug into the right pins, and then you're driving your motors. But let's say you want to access sensor data. There are sensors built into the motors, but there's also external sensors that Lego provides. It's all the same connector. And also you can add external sensors that are not Lego things. This is a little attachment that I created for my robot here. This has one of the Lego color sensors, and we'll show that in a moment. It also has a breadboard on top, so if you want to do some kind of prototyping with your electronics, then plug in your circuits into here. And then also on the bottom, I have the SparkFun optical tracking odometer sensor, and so this can be used to track the robot as it drives around, sort of like a computer mouse. And so I'm going to get these plugged in here, and this module just slots straight into the front here. And I need to get my things plugged in, so I'm going to turn off power just for a moment as I do this. Stand by 1 moment. All right, and the last thing is we'll plug in the quick cable for that optical odometer sensor, and it's also got a matching quick connector that can be daisy chained, so if you have multiple sensors, you can just chain them all off of one quick connector, which is a nice benefit over the Lego system. You can't daisy chain things, so you're just limited to the 6 devices you can plug in, whereas here you can just chain as many as you want. It's great. We'll power this back up again, And you can see now we've got a light on the light sensor here, so it's measuring reflectance to various things. And what I'm gonna do is I'm gonna select my second program on here, which is called my sensor demo. And so if I run this, then first thing we're gonna see is this grid on the right. That is the tracking as found by the optical tracking odometry sensor. So as I move the robot around, it is fully tracking the robot motion. I'm not even using the encoder wheels at all. So no dead reckoning needs to be done. It just does all the tracking for you. And you can see the coordinates are displayed in the bottom left corner here. Similarly, in the top left corner, we're seeing the sensor data from the color sensor. So if I put a colored object in front of here, put the yellow spike hub, then you can see the background color is turning kind of yellow, because that's just the color that the sensor sees. And we can see the RGB values. Similarly, if we flip this around to the white side, then you can see we're getting a white color. And so, I'm getting data straight off of that color sensor with the breadboard. This kind of shows the kind of possibilities that you can do of having hobby-level electronics interfacing with LEGO devices to expand the capabilities of LEGO robots. Hope you enjoy this. Let us know if you'd like to see something more polished. This is not like a super, big. This is not like a tutorial or a guide or anything. It's more just kind of showing off a fun project we did. But if you would like to see something more polished around this, let us know. We'll see if we can make something happen. As always, stay safe, be kind, and happy roboting.